I'm Stephanie Sulit. In this tutorial video, we will learn and we will talk about limits. I will separate our discussion into 4 parts. Number 1, definition of limits. Number 2, limits using table of values. Number 3, limits using graph. Number 4, limits at infinity. First, definition of limits. What is the definition of limit? A limit tells us the value that a function approaches as that function's inputs get closer and get closer to some number. The formula of this is this. We are going to use this formula for solving limits. You can read this as the limit of f of x as x approaches c is L. To understand this, let's have an example. Number 1, limit of 1 plus 2x as x approaches 2. To visualize our problem, let's have our x-axis. Our problem said our x approaches 2. It means our x is getting closer and closer to 2. We can approach 2 from the left and 2 from the right. We will have table of value to answer this problem. We will have a table of value approaching 2 to the left and another table of value in approaching 2 to the right. We will start approaching 2 to the left. Our x value is this 1.9, 1.99, 1.999. Is a substitute to our function. Our answer is 4.8, 4.98, 4.998. You can choose any number in our x value as long as it approaches 2. From the left, we can see our y is approaching 5. And our right naman, 2.1, 2.01, 2.001. Substitute to our function. Our answer is 5.2, 5.02, 5.002. And our right is also approaching 5. So the answer of the limit of 1 plus 2x as x approaches 2 from the right, from the left and right is 5. Now we'll have a following values. They are called one-sided limit because they are specific in one direction, one from the left and one from the right. If it's not raised to negative and positive that our x approaches to, they call two-sided limit. Take note that our two-sided limit will exist if our one-sided limit has the same value. In this case, they have the same value in our one-sided limit, so the final answer is the limit of 1 plus 2x as x approaches 2 is equals to 5. Let's have another example to understand limit. Number 2, limit of x squared minus 4x as x approaches negative 2. To visualize our problem, let's have our x-axis. Our problem said our x approaches negative 2. It means our x is getting closer and getting closer to 2. We can approach 2 to the left and 2 to the right. So we will start approaching negative 2 to the left, and the next is approaching 2 from the right. Our x values will be negative 2.1, negative 2.01, negative 2.001. Substitute. Our answer in y is 12.81, 12.0801, 12.008001. From the right, negative 1.9, negative 1.99, negative 1.999 is substitute in our function, 11.21, and so on. Our x values from the left, we can see our y is approaching 12 and our left is also approaching 12. So the answer of the limit of x squared minus 4x as x approaches negative 2 from the left and from the right is equals to 12. Those values are one-sided limit. If it's not raised in positive and negative, that is two-sided limit. Once again, take note that two-sided limit will exist if our one-sided limit have the same value. Since our one-sided limit is the same, so our final answer is the limit of x squared minus 4x as x approaches negative 2 is equals to 12. Our next is limits using graph. So we need to know the answer of our tree function in the side. So let's start the limit of f of x as x approaches 6. We will approach 6 in the both sides. As we approach 6 to the left side, we see that our x approaches 6 is getting closer to 1. Our right side also is approaching 1, so our answer is 1. Our next is the limit of f of x as x approaches 4. We will approach 4 in the both sides. As we approach 4 to the left side, we see that our x approaches 4 is getting closer to 3. In our right side, we can see that our x approaches 4 is also getting closer to 3. So our answer is 3 based on what we are seeing in the graph. The last one is the limit of f of x as x approaches 2. Our problem is interesting because our x approaches 2 from the left is getting closer to 2. But our x approaches 2 from the left is getting closer to 5. So our final answer is the limit does not exist. Take note that two-sided limit will exist if our one-sided limit has the same value. Next is limit at infinity. In this topic, we will also use table of values, and our x values is getting bigger and bigger because it will approach infinity. Our formula is this, just like our limits, but the difference is we will approach positive or negative infinity. So let's have our example. Limit of 2x squared as x approaches positive infinity. You can choose any values as long as it is getting bigger because it is approaching infinity. In my problem, I write 10, 30, 50, 100. We will substitute our x value in our function, which is the limit of 2x squared as x approaches positive infinity. So, our answer 200, 1,800, 5,000, 20,000. The final answer is the limit of 2x squared as x approaches positive infinity is equals infinity. Let's have another example. Limit of x squared minus 5 as x approaches negative infinity. We will do the same step to answer our problem. We will substitute our x values in our function. Our x value is negative 10, negative 30, negative 50, negative 100. And substitute to our function. Our answer will be 95, 895, 2,495, 9,995. Final answer is the limit of 2x squared as x approaches negative infinity is equals to positive infinity because our x does not have negative, and even if our given is as x approaches negative, our final answer will definitely be positive infinity. That's all. Thank you.
Hey guys, it's me Jareen, and in this video, you're going to learn about the derivative by definition formula. So without further ado, let's get started. So the first thing you have to take note of is the derivative by definition formula. This is used in finding the derivative of any function. This formula is read as f prime of x is equals to limit as h approaches 0 of f of x plus h minus f of x all over h. So we have some examples here, and example number 1 is solve for f prime negative 2 given the function f of x equals to x plus 5. Again, we're going to use this formula, and the first thing we have to do is to substitute this negative 2 to the x. So we're going to get f of negative 2 plus h minus f negative 2 all over h. Then we're going to substitute this negative 2 plus h and negative 2 to this function. So it will be 2 of negative 2 plus h positive 5, and we're going to substitute this to this. So we're going to get 2 negative 2 plus 5. Then after that, we're going to perform the necessary operation to simplify it further. We're going to distribute this 2 to negative 2 plus h. We're going to get negative 4 plus 2h. Then copy positive 5. Then here, we're going to multiply 2 to negative 2, negative 4, then copy positive 5. Then after that, we're going to remove the unnecessary parentheses and combine the like terms. So, negative 4 plus 5 is 1, copy positive 2h, and negative 4 plus 5 is 1. Then after that, we're going to cancel negative 1 and this positive 1, we're going to get 2h over h. Then after that, we're going to cancel again this h. We're going to get 2. The final answer is written as f prime negative 2 is equals to 2. Then moving on to the next example, we have to solve for f prime 3 given the function f of x equals x squared positive 3x minus 5. Again, we're going to repeat the same process what we did on example 1. We're going to substitute 3 into the x. So we're going to get f of 3 plus h minus f of 3 all over h. Then we're going to substitute this 3 plus h and 3 to this function, this x squared positive 3x minus 5. So we're going to get 3 plus h squared, positive 3 of 3 plus h minus 5, then substitute this 3 to this x squared positive 3x minus 5, 3 squared positive 3 multiplied to 3 minus 5. Okay. After that, we're going to perform the necessary operations to simplify it. Here, we're going to remove the unnecessary parentheses and combine the like terms. So here, positive 9 minus 5 is 4, copy 3h, and this we just expanded this 3 plus h squared, then we're going to get h squared, positive 6h, positive 9, copy. Then here, we're going to combine. 9 plus 9 is 18 minus 5 is 13. Then after that, remove the parentheses. And combine. Combine like terms. Copy h squared. Then combine positive 6h and positive 3h. We're going to get positive 9h. 9 plus 4 is 13. Then remove the bracket of 13. Then copy it. Then after that, remove again the bracket, and we're going to cancel negative 13 and positive 13 because it is equals to 0. And so copy this, h squared positive 9h over h. Then after that, we're going to factor it. H of h plus 9 over h. Then again, cancel h. We're going to get h plus 9, and the final answer is f prime 3 equals to 9. So it may seem daunting at first because of its long process, but once you get used to it, it's gonna be easier. And that's all for today, and thank you for watching.
In this video, we are going to discuss about the basic rules of derivatives. So in the previous video, you guys discussed about how to get the derivative of the function using the definition of derivatives. Now in this video, we are going to get the derivatives of the functions using the basic rules. So what are the basic rules of derivatives? There are 5 basic rules, and they are: first, the constant rule; second, the identity rule; third, the power rule; next is the constant multiple rule; and lastly, the addition-subtraction rule. So first, the constant rule. The derivative of any constant is equal to 0. So the derivative of every constant function of c is an element of a real number is equal to 0. So 2dx is equal to 0 because it's an element of a real number. Number 2 is an element of a real number. And 100dx is equal to 0. And 45dx is equal to 0. Next is the identity rule. The derivative of any identity function is equal to 1. X dx is equal to. So RDR is equal to 1, and any function of x is equal to 1. Next is the power rule. F of x is equal to x raised to n. Then the derivative of f of x, or the f prime x, is equal to n x raised to n minus 1. So x raised to n, where n is an element of a real number, consider the exponent, which is n, and multiply it to the variable of x. After multiplying it, subtract 1 from the exponent. So we'll be able to do this. Nx raised to n is 1. The derivative of a variable raised to n is equal to n multiplied by the variable raised to n minus 1. So for you to further understand the explanation, here's some example. So first, get a derivative of x cubed, or x raised to 3. So 3, multiply it to the variable of x, which is 1. 3 times 1 is 3. After multiplying it, subtract 1 from the exponent. So you will get 2. So our final answer should be 3x raised to 2, or 3x squared. Now our second example is x raised to negative 5. Negative 5 multiplied to the variable of x, which is 1, is negative 5. After multiplying it, minus 1 from the exponent. So negative 5 minus 1 is negative 6. Our final answer should be negative 5x raised to negative 6. Now our fourth basic rule is the constant multiple rule. The derivative of a function that has a factor c is equal to the derivative of the function multiplied by c. So c multiplied by f of x is equal to the derivative of f of x multiplied to c. For you to further understand it, here is some example. 7x dx. So in our first example, which is 7x dx, we are going to apply the identity rule, where x dx is equal to 1. So 7 times 1 is 7. That's our final answer. Now our second example is 8x raised to 3, or 8x cubed. So first, we are going to get the derivative of x cubed by using the power rule. So 3 multiplied to the variable of x, which is 1, and after multiplying it, subtract 1 from 3, which is 2. So we are going to get 3x squared. The derivative of x cubed is 3x squared. After getting the derivative of x cubed, we're gonna multiply the 8 to the variable of 3x squared. So 8 times 3 is 24x squared, or 24x raised to 2. Our last rule is addition or subtraction rule. The derivative of a multiple function or terms being added or subtracted together is equal to the sum or difference of the derivative of the equations or terms. So when you see two functions that are being added or subtracted to each other, you consider them separately. After considering them separately, you're going to apply the rules that we have discussed. So here's some example for you to further understand it. So first, find the derivative of 5x plus 10. So we're going to consider them separately, okay? So what is the derivative of 5x? So we're going to use the power rule. The exponent of x is 1. So 1 times 5 is 5 minus 1 from the exponent, which is 0. So we are left with 5. And what is the derivative of 10 dx? Now we discussed that in the constant rule, where all element of a real number is equal to 0. So 10 dx is equal to 0. So we are only left with 5. That's our final answer. Now for the next example, find the derivative of x squared minus 4x plus 100. So first, what is the derivative of x squared? 2 times the derivative of x is 1. So 2x, after multiplying the exponent, minus 1. So 2 minus 1 is 1. So we are left with 2x for the derivative of x squared. Minus 4x. What is the derivative of 4x? Now we're going to apply the power rule again. So the exponent of x is 1. So 1 times the variable, which is 4, is 4. After multiplying it, subtract 1 from the exponent, and it's 0. So we are left with 2x minus 4. Next is 100. What is the derivative of 100 dx? Again, 100 is an element of a real number, and in constant rule, it's always equal to 0. So 100 is equal to 0. So our final answer should be 2x minus 4. Now for our last example, what is the derivative of 2x cubed minus 4x squared plus 9x minus 1. First, consider them separately. What is the derivative of 2x cubed? So we're going to apply the power rule again. So 3, the exponent of x, multiply it to 2, the variable of x, is 6. After multiplying it, minus 1 from 3. So you're left with 6x squared minus 4x squared. So what is the derivative of 4x squared? So again, we're going to use the power rule. 2 times 4. 2 times 4 is 8. After multiplying it, minus 1 from the exponent, we're left with the exponent. So we will get 8x for the derivative of 4x squared plus 9x. So again, we are going to apply the power law. So what is the exponent of 9x? It's 1. So 1 times 9 is 9. After multiplying it, minus 1 from the exponent. 1 minus 1 is 0. So we are left with 9. Minus 1. So what is the derivative of 1? So 1 again is an element of a real number, and in the constant rule, all element of the real number is equal to 0. So our final answer should be 6x squared minus 8x plus 9. So these are the 5 basic rules of derivatives that we have discussed. The constant rule, the identity rule, third the power rule, fourth is the constant multiple rule, and last the addition subtraction rule.
Last lesson for today is about additional derivative. But before we move on to our next topic, let us recall our previous lesson, which is the basic derivative. Basic derivative has 5 rules, which are the constant rule, the identity rule, constant multiple, power rule, and the addition subtraction rule. So, our lesson has 2 objectives. And those are to identify the differences between the 3 rules and to be able to solve the problems using the 3 different rules. So additional derivative has 3 different rules, which are the product rule, the quotient rule, and the chain rule. First is the product rule. Product rule has the formula of the derivative of f of x times g of x is equals to f prime of x times g of x plus g prime of x times f of x. So using this formula, let's solve for our example here. So let's find the derivative of the quantity of 5x minus 3 times the quantity of 2x squared minus 4x plus 1. So based on the formula of the product rule, we need to find the derivative of f of x, which is the 5x minus 3. So that will be 5. Then copy the g of f of x, which is 2x squared minus 4x plus 1. Then plus the derivative of g of x, which is 2x squared minus 4x plus 1, giving us 4x minus 4. Then copy the first term, which is 5x minus 3. Next step is using the distributive property of multiplication, or the FOIL method. In our example here, we have to use the distributive property of multiplication. So, 5 times 2x squared is equals to 10x squared. 5 times negative 4x is equals to negative 20x. Then 5 times 1 is equals to 20. Then after that, we will be using the FOIL method. So, the quantity of 4x minus 4 times the quantity of 5x minus 3. The answer will be 20x squared minus 32x plus 12. After that, we will be combining the like terms. So 10x squared plus 20x squared is equals to 30x squared. Then, negative 20x plus negative 32x is equals to negative 52x. Then, 5 plus 12 is equals to 17. So our final answer would be 30x squared minus 52x plus 17. Now, let us go back for our next rule. Next is the quotient rule. Quotient rule has the formula of the derivative of the quantity of f of x over g of x is equals to g of x times f prime of x minus f of x times g prime of x all over g of x squared. So using this formula, let us solve for our example here. Let us find the derivative of the quantity of x squared minus 4x plus 5 over the quantity of 2x minus 5. So based on our formula, we just copy the g of x, then find the derivative of f of x, which is x squared minus 4x plus 5, giving us 2x minus 4. Minus, copy the f of x, then the derivative of g of x, which is 2x minus 5, giving us 2, over 2x minus 5 squared. Next step is using the distributive property of multiplication, or the FOIL method. In our example here, we have to first use the FOIL method. So, the quantity of 2x minus 5 times the quantity of 2x minus 4 is equals to 4x squared minus 18x plus 20. Then minus the quantity of x squared minus 4x plus 5 times 2. Here we will be using the distributive property of multiplication. So x squared minus 4x plus 5 times 2 will be 2x squared minus 8x plus 10. Then, copy the denominator. After that, our next step is to combine the like terms. So, 4x squared minus 18x plus 20 minus 2x squared minus 8x plus 10 can give us 2x squared minus 10x plus 10. Over, copy the denominator, 2x minus 5 squared. Always remember that we don't need to expand our denominator anymore, and we can write it as it is for our final answer. Now, our final answer is 2x squared minus 10x plus 10 all over the quantity of 2x minus 5 squared. Now for our last rule. So the quotient rule has the formula of the derivative of f of g of x is equals to f prime of g of x times g prime of x. Chain rule seems complex, but for me, it is the easiest among the 3 rules. So, going back, let us use the formula of the chain rule in solving the example that we have here. So the quantity of 2x plus 3 to the 5th power would be our example. So note that we also have to look at our g of x, which is 2x plus 3 as the x of our f. So based on our formula here, let us first find the derivative of f of g of x using the power rule that we discussed during the lesson about this derivative. That would give us 5 times the quantity of 2x plus 3 to the 4th power, then times g prime of x. So our g of x here is 2x plus 3. The derivative of 2x plus 3 is 2. So our next step is to simplify our constants. The constants here are 5 and 2. So 5 times 2 is 10. Then copy the quantity of 2x plus 3 to the 4th power. Our final answer would be 10 times the quantity of 2x plus 3 to the 4th power. So that would be all for our lesson. I hope you understand our lesson.